Okay, so this week we talked about probability distributions. And what we're going to do in this video, I'm going to continue on talking about probability distributions. Um, and I'll do a couple more examples on binomial, and we'll do a couple more on Monday or Tuesday. So a probability distribution function, the way that I'm going to say this is with the, whoops, I'm not on any color. I'm going to go ahead and say this as a PDF. So that's abbreviation for probability distribution function. It's just a function that provides the probabilities of different possible outcomes in an experiment. So we said in class that the definition usually is given to you as a table, as a graph, or a formula. And one thing that you always have to know is that all of these probability distribution functions, just like regular probability, they all must add up to 1. Okay, so I gave you here 3 different types of probability distributions. So if I say find the probability distribution of this, you can either give me a graph, a table, or a function, some sort of formula. However, usually making a graph and a formula can be really hard. So this is the one that we're mainly going to be using. So the table. Now notice that they all must add up to 1. So what I mean is here are the outcomes. So the table's a little bit easier to see. Here are all my outcomes. And these are the probabilities of this outcome. Okay, so if I get a 0, I get 0.3. If I get a 1, I get 0.7. And as you can tell, if I add up all these probabilities, I'm gonna get 1.0, which is 1, and that's really what we want. So with a table, you just have to make sure that all of our probabilities add up to 1. For a graph, though, a graph, as we will see next week, a graph, how is it possible for me to add up things on a graph? Well, if you've taken calculus, you know that the area under a curve is actually the sum of all individual rectangles, Riemann sums. But if you don't know any calculus, it doesn't really matter, because all the probability is when you have a graph is the area under this curve. So we want to find out what this area is. And if you remember the area of this triangle, the area of a triangle is 1/2 base times height. So 1/2, the base in this case goes from 0 to 2. So you have a base of 2. The height in this case is just going to be equal to 1. Okay, so this is going to be times 1. So clearly 1/2 of 2 is just going to give me 1. So this is 1 times 1, which gives me 1. So the area of a graph is actually the probability. Okay, so here area is the same thing as probability. Okay. Now, what about this one? If we have a formula, well, in order for me to make sure that everything adds up to 1, I need to make sure that my outcomes, which are these are my outcomes, all, when I plug them into the formula, I should get up 1. So I need to add up all the probabilities. So summation, which means adding up, I'm going to add up all the probabilities. So when probability of x equals 0, so when x equals 0, and also probability when x equals 1/2. Okay, so that's what I'm going to add up. Okay, whoops, I forgot the addition sign. Okay, so I am going to be adding up all of these probabilities. So plus probability. Okay, so the probability of x equaling 0, let me plug in 0 in here. So I'm going to get 2 times 0 plus 2 times 1/2. So this is just going to go to 0. Half of 2 is 1, and I'm going to get 1. So you see that the probability is also equal to 1. So these are three different ways that we can describe probability distributions. So either with a graph, with a table, or with a formula. Okay, so something else that I really want to talk about is random variables. Now this variable is something very, very different in the sense that this variable is determined by chance. Okay, so actually all of these x's, right, these x's are all random variables. So the values of x that can be plugged in is just 0 and 1/2. For these it's just 0 and 1. For here it's all the numbers between 0 and 2. Okay, so x is just determined, it's a variable determined by chance. And there's 2 different types of random variables. So let me write random variables. Okay, and the 2 different types of random variables that there are is you can have a discrete random variable or you can have a continuous random variable. Okay, so these are the two different types of random variables that we have. Okay, now if you have a discrete random variable, usually these variables are expressed as whole numbers. So numbers like 0, 1, 2, 3, all of these are discrete numbers. I mean, you can also have -1. You can have all these negatives, positives. So basically all of our integers. Okay, so those are what we describe discrete random variables. Now, continuous random variables is any number. Okay, any number that you can think of that has decimals, that also has percents. It can also be fractions. It can even be whole numbers and integers. Okay. So notice that the difference here is that the continuous random variables contain decimals, while discrete only contains only the whole numbers. Okay, so those are the two different types of random variables. So let me give you a couple of examples. Okay, so let's do this problem. So determine if the following are discrete or continuous variables. Okay, so the number of siblings. So is this continuous or is it discrete? Well, the number of siblings, if you think about it, discrete random variables can only take whole numbers. Continuous random variable can take whole numbers and decimals. However, can you have half a sibling or a fourth of a sibling? Not really. So this will be considered discrete. So this is a discrete random variable because it can only be expressed as just whole numbers. Okay, the number of people in a passing car. So here we are modeling the number of people. So the number of people in this case would be discrete. Okay. The weight of a submarine. Well, the weight of a submarine can either be 180 pounds, which is very little, not too big of a submarine, 700 pounds, 1,000 pounds, right? 1,000 pounds. It can also be, I don't know, but it can 1,180 pounds, but I can put a 0.5 in there. So there's decimal answers that I can actually have too for a weight of a submarine. So this is actually continuous, because this can be expressed as regular whole numbers, but if you think about it, you can also have 0.5, 0.7 decimal answers. So the weight of a submarine will be continuous. The amount of time for the next bus to appear, well, that one is also going to be continuous because time itself is continuous. It's not discrete. Okay, so those are two different types of random variables, discrete and continuous. So we can model all these using probability distributions, which is what we're going to do in the next video.